Have you ever wondered how an AI, a neural network, actually thinks? It sounds super complicated, right? But what if I told you the basic idea is something you do all the time without even realizing it? Okay, let's do this. We're going to break down one of the most powerful technologies out there using a scenario that's surprisingly simple.
So picture this. You walk into a party. Music's thumping, people are everywhere, and you instantly start taking it all in. And right away, you're faced with that classic dilemma we've all been through. Is this party going to be awesome, or should I just make a quiet exit?
Believe it or not, that little calculation you're running in your head, weighing the good versus the bad, that is a perfect, and I mean perfect analogy for how a neural network makes a decision. Your brain is basically firing up its own little network of opinions.
Okay, so step one is just gathering the facts. In the AI world, this is called the input layer. For you at the party, it's just your raw observations. How's the music? Are those actual good snacks or just a sad bowl of pretzels? And maybe the most important question, how many of my friends are here? These are your starting data points.
So what do you do with all that info? Well, a network uses something called hidden layers. Now just think of these as your friends at the party. You go up to them and say, okay, here's the situation. And each friend weighs that information differently, right? Your music snob friend only cares about the playlist, while your foodie friend makes a beeline for the snack table. Each one gives you their own take on the situation.
But let's be real, you're not going to listen to everyone, especially the friend who complains about everything. This is where an activation function comes in. A really common one has a super simple rule. Just ignore the negative stuff. You're only going to listen to the good vibes, the friends who are genuinely excited. All the complaints? Yeah, they just get filtered out.
All right, so you've listened to all the positive advice from your trusted friends, and now it's time to make the final call. That's the output layer. It takes all those positive opinions, mashes them all together, and spits out one single clear decision. Stay or leave. So let's just run that back real quick. You start with your observations. That's your input. That info gets processed by your friends. Those are the hidden layers. And all of that leads to your final decision, the output. See? Simple. Observation, processing, action.
But this is where the real magic happens. Because making one decision is fine, but how do we, and how does an AI, actually get better at it for next time? How does it learn from what happened?
Well, it's all thanks to a process with a very nerdy name, backpropagation. Don't worry about the word, it's just a fancy term for feedback. Let's say you decided to stay at the party and you had the best night ever. That's some serious positive feedback. Or maybe you left and then got texts all night about how legendary it was. That's negative feedback. The network uses that outcome to figure out if it got the answer right. And based on that feedback, the network actually changes. That's the solver method. It's exactly like you thinking to yourself, you know what? My snack-loving friend gave me terrible advice, but my music-loving friend was totally right. So next time you're going to trust the music lover's opinion a little bit more. The network literally strengthens the connections to the friends who give the best advice.
And that's the big reveal. If you followed that whole party scenario, the observations, the different opinions, the final call, and then learning from how it all turned out, then hey, congratulations, you totally get the basic fundamental idea of how a neural network actually works.
Okay, so it's a fun analogy, a neat little party trick, but why is this so important? Why does this one simple idea of learning from feedback unlock capabilities that are, well, changing the entire world? Let's get into the real superpowers this thing has.
I mean, just look at this. When you put a neural network up against another really smart model like a random forest, it's not even a fair fight in some areas. For things like recognizing what's in a picture or understanding language, you see excellent for the neural network and poor for the other one. They can do things that feel almost human.
So let's translate that chart into actual superpowers. They can learn features automatically, meaning you can show them a million cat photos and they figure out what catness is all by themselves. They're amazing with images and sound. They get sequences, like the order of words in this very sentence, and the one that bends your brain, they can generate brand new stuff from scratch.
And listen, this isn't some abstract theory or science fiction. This technology, born from that same simple logic you used at the party, is already all around us. It's probably in your pocket right now.
You ever search your photo library for dog and it just finds all the pictures of your dog? That's a neural network recognizing patterns, just like you spotted your friends at the party, but doing it across thousands of your photos in a split second.
And when you ask your phone for directions, that's a neural network that understands the sequence of your words. It gets the context. It's processing your sentence, kind of like your friends processed your observations about the party.
And of course, there's the really wild stuff. All that incredible generative AI that can create a beautiful piece of art just from a few words you type, that's the ultimate superpower in action. It's not just seeing patterns, it's understanding them so deeply that it can create something totally new.
So, what's the big takeaway here? It's that this one single idea, this really elegant concept of a network learning from its mistakes, is the engine behind countless new futures that we're only just starting to wrap our heads around. And that kind of leaves us with one last big thought to chew on. We've built this thing that learns from experience, that gets better over time, a technology that, in many ways, mirrors how our own minds work. So the real question is, as these systems get smarter and smarter, what are they eventually going to teach us about ourselves?